I'm sure you learned this in geometry. Okay, we are starting Unit 5.2, Day 1. We're just talking about polynomials, okay? So a polynomial is an expression. Who knows what an expression is?
It's a phrase.
A phrase. Kinda, but like a math expression.
Something that expresses something.
Oh my gosh. Okay, it's like an equation with no equal sign. Okay? So that's all polynomials are, just expressions. But with only addition, subtraction, and multiplication. Okay, so there's no division in a polynomial. Okay? So who knows what terms are? Anybody? Not you. Okay, terms are just parts of your expression. So, terms are parts of the expression separated by plus and minus. So, addition and subtraction. Okay, so how many terms? Well, if they're subtracted, if they're separated by addition and subtraction, here's some addition. So how many sides are there? 2. So this is 2 terms. Welcome. Okay, so this one though, here's addition, here's subtraction, here's addition. How many terms is that? 5. 1, 2, 3, 4, 5. So this is 5 terms. So there are fancy names depending on the number of terms. Okay? So there will always be at least one term, and one term is monomial. Mono means one, right? So one term is a monomial. What? 2 is binomial. You're right. Okay, why do they call a bicycle a bicycle? Because it has 2 wheels. Bi means 2. What do they call? Why do they call a tricycle a tricycle? Because it has 3 wheels. So this would be a trinomial. Now, I accidentally put an extra blank in here. I don't know why. Okay, but 4 or more. No. We just call it polynomial. It's just a polynomial. 6, polynomial. 7, polynomial. 8, 9, 10, 11, 12, polynomial. Okay? Any questions with that? Now, I want you to know that technically, you can call these 3 a polynomial as well. But if you can be more specific, why not be more specific kind of thing, okay? So knowing that, we're moving on. So it says, degree of a polynomial is the sum. What does sum mean?
Total.
Add, total. Okay, of the exponents of its variables per term. Okay, the term with the highest degree is the degree of the polynomial. So I'm going to show you what that means here in a second. Thank you, Jose. None of y'all told me, except Jose. Yeah?
For this, are we using anything in the other units?
There will be different things, yeah. Okay, I accidentally didn't share my screen with the online kids, so I'm going to give them a minute if they want to write this down. Also, those of you online, I do have packets outside my door. They're taped to the side of my building. I think all of y'all were in my class before, so all of you know. but they are out there if you would like a packet. Okay, so it says, now we're talking about degrees. So it says, what is the degree of this? Okay, so the difference with degrees is you have to look at it per term. Phone's away. So here is one term, right? And here is another term, correct? Okay, if you notice, it says of the variables, so we're only looking at the letters, so we're not paying attention to 12, okay? And it says it's the sum of the exponents of the variables per term. So looking at this term, the sum of the exponents, what's 7 plus 4? So this term has a degree of 11. Okay? Now this one, what's 4 plus 5? Has a degree of 9. And it says the term with the highest degree is the degree of the polynomial. Which one's the highest? So this is an 11th degree. It's technically a binomial if we want to get super fancy. Does that make sense?
Can I use a degree symbol instead of
Just put 11. Yes. Okay, so if you read the explanation, it says it is the sum of the exponents of the variables per term. So I separated the two terms, right? Variables means letters, so I don't need to pay attention to this 12. Okay? And it says the sum of the exponents. Well, 7 plus 4 is 11, 4 plus 5 is 9. And then it says the term with the highest degree is the degree of the polynomial. 11 is higher than 9, so it's an 11th degree binomial. Okay? Now, degrees tell us other things also. They tell us what type of equation it is. Okay, now when it has multiple letters like this, I can't sit here and tell you this is a certain type of line. Okay, but when they have a single variable like just x or just y or just one letter, and we were to graph it, we can have linear, we can have quadratic, we can have cubic, we can have all those things that we've learned, right? Okay, so if it has a degree of 0, which is possible, okay, it would just be a constant. And I'm going to show you what that looks like. So an example would just be a number, 7, because it says exponents of variables. If there's no variables, there are no exponents. Does that make sense to add? So that's how that's a 0. It's just a number, no letters. Okay? A degree of 1 is going to be linear. A degree of 2 is going to be quadratic. A degree of 3 is going to be cubic. And if it has a degree of 4 or more, there is nothing fancy to write there, so you're just going to give the number. Like we did here, where we just wrote 11th degree. Okay? Any questions with that? Comments, concerns? Okay, so these last couple ones, these we're going to label, these 4. Okay, now one thing I want you to know is anytime I'm asking you the degree or the number of terms, you have to simplify it first. So if it can simplify, simplify. Okay, so look at this first one. Nothing here can combine. Okay, how many terms is it? 4. 1, 2, 3, 4. Okay, which means we would just call it a polynomial, right? Okay, and what's the highest degree? This is 2. What's this one? What's this one? What's this one? 0. Okay, so what was the highest degree? 3. So what does that mean? It's a cubic polynomial. Okay, how many terms does this one have? 2. And what's the highest degree? Yeah, technically this doesn't have one, but it means it's 1 if there's a letter at all. And this has no letter, so it's 0. So this is a linear binomial. Okay, so looking at these next two, this is where I'm kind of talking about simplifying. What's 3 squared? 9. Don't let that exponent throw you off, because remember, it said exponents of variables. Is 3 a variable? No, so I don't want to look at that 2. That's why I simplified it so it doesn't throw me off. Okay, so what is the degree here? 3. And what's the degree here? 4. So it's a 4th degree. How many terms?
5.
Binomial. Does that make sense? Okay. Now looking at this last one, what's anything times 0? 0. So 0 times x to the 5th power is just 0. So don't let this x to the 5th power throw you off, because the whole thing just ends up equaling 0, which makes it a what? A constant monomial. Constants should almost always be in monomials, because remember, you're supposed to simplify first. Because if you have 4 plus 7, yes, that's a constant. Yes, it looks like a binomial, but you need to simplify it and it's still a monomial. Does that make sense? Okay. Okay, the last two are simplifying. Okay, combining like terms. That's all you do in simplifying expressions, right? Okay, so here it says find the perimeter. How do you find perimeter? Huh? Add all the sides. So we have y minus 5 plus y plus 2 plus 3y plus 1 plus 2y plus 4. So what are my like terms? Everything with a y, right? So here's a y. This is a plus y. This is a plus 3y. This is a plus 2y. Why do you think I circled the symbol in front as well? It tells you if it's positive or negative. Okay? So what's y plus y? Plus 3y. Plus 2y. So I have 7y. And then what's negative 5 plus 2 plus 1 plus 4? 2. Positive 2, right? Okay, the way I think about that, this is super weird, is 4 plus 1 is 5. Well, positive 5 and negative 5 cancel, and all you have left is a 2. Could you have technically typed it in your calculator? Yes. Is that what you did? What's different about this one? There's parentheses. What's in the middle of the parentheses? Minus. Okay, so we have this classroom that y'all are in, and we have that classroom that they're in, right? If we subtracted that classroom from this building, don't everybody, don't listen to my English, okay? Doesn't everybody in there have to leave as well? Yeah, if we take out that classroom, everybody inside has to leave. If you subtract a set of parentheses, everything inside that parentheses has to be subtracted. So the way we do that is we just simplify by distributing the negative, okay? So all a negative does is make everything opposite. If it was positive, it becomes negative. If it was negative, it becomes positive, right? Isn't that what a negative does? So this positive 8 becomes a negative 8. This positive 2 becomes a negative 2. This negative 5 becomes positive. This negative 7 becomes positive. And since I distributed it, I'm going to make it a plus. Now I can ignore all of the parentheses. Okay, if you need to rewrite it, you can. If you don't need to rewrite it, Don't. So I'm going to go through, I'm going to pick out everything that's alike. Okay, so I'm going to start at the beginning. This is cubed. Are there any other cubes? Anything else with a third power? Yeah, this plus 5 back here. Okay. Here's just an x. Is there anything else with just an x? This negative 2. Okay, this is squared, and this is squared, and this is to the 4th power, and there's nothing else like it. Now, when doing these and combining, to do it proper, the highest degree goes first. So what has the highest degree? Yeah, it's 4. So 7x to the 4th power goes first. And if you need to cross it out when you've used it, cross it out. What goes next? To the 3rd power. So what's negative 4x cubed plus 5x cubed? 1x cubed. Do I have to put that 1? Okay, then what? Yeah, squared. So what's 10x squared minus 8x squared? Positive 2x squared. And then I have this negative 3x minus 2x. Negative 5x. And this became a 4th degree polynomial. This became a linear binomial. Does that make sense? Okay. Any questions for me? Now I do want to look at one of the practice problems really fast. I'll put this back up here in just a second. Okay, if you look at the top, it just says what's the degree, what's the number of terms. Okay, you don't have to give me the fancy words. You can just use the numbers because that's all it asks pretty much. Okay, if you use the fancy words, that's fine too. It's good practice. If you want to use both, that's fine too. Okay, now at the bottom it says to find each sum or difference and show all your work. Okay, you'll notice the first two are addition. So do you even have to pay attention to those parentheses? No, because adding it doesn't change anything. So you don't even need to worry about those parentheses. Now, these three and this one have subtraction. So this one you'll distribute your negative just to the parentheses after that negative. Just to the parentheses after that negative. So you stop when you get to this plus on the outside. That means nothing here changes, right? Okay, now these two, though, you'll notice it's a negative number on the outside. So that means you have to distribute negative 4. So here, distribute your 2, so that becomes 24y squared minus 16y plus 12, right? All I did was distribute that 2 in the front. And now I'm just distributing a negative 4. So negative 4 times 3y squared becomes negative 12y squared. Negative 4 times negative 4 is positive 16y. Negative 4 times 2 gives me negative 8. Now combine like terms. Does that make sense? You have to distribute. So I distributed this 2 and the negative 4. That's how I got all those numbers. Okay? So this is what you're doing. If you have questions, what should you do? Ask. Okay? Ready, set, go. You will not have class time on this tomorrow, just so you know.